Hey, Algebra 1, this is Unit 1, Lesson 4. Let's dive in and do the homework. I'm asking you to do numbers 1 through 6 tonight. So that's basically the front side of this paper. I would have stopped it at 4, but these other two, they go along with number 4. So, all right, let's look at this. We learned two new vocab words today, arithmetic and geometric sequences. And so arithmetic sequences are those ones that have a constant difference or a constant a constant difference. They are either adding or subtracting, either increasing or decreasing by addition or subtraction. Geometric ones are the ones that have that constant ratio. They are either multiplying or they are dividing. Their terms. So, all right, we look at this. 1,000 goes down to 2. 1,000 goes down to 200 to 40 to 8. There's no way that this is going to subtract the same amount each time. The difference between this is 800, and we're not taking away 800. So this one's got to be geometric. It's got to have that constant ratio. Now, it doesn't tell us to do anything else. We just had to identify that. As a teacher, I just want you to know this is all you had to say. But I do want to take the time to find out, well, what is the constant ratio? Let me take these two numbers, 8 over 40, and just reduce them. So, 8 and 40 are both divisible by 4 twice, and 10. And let's see, that reduces down to 1/5. So that is our constant ratio, that 200 is 1/5 of 1,000. Let's look at the next one, 2, 4, 16, 250. Oh, okay, there's no way that we're adding the same amount each time. This one must be geometric. All right. So geometric becomes very easy to see because of how fast it's decreasing or increasing. We saw those curves in class that were either like on the graph, they were either going like starting out high and going, or they were starting out high, and they are starting out low and going like, and they like skyrocketed. Now, by the way, let's see. This one is a decreasing one. It would look more like that. And this one's an increasing one. It would look more like that. Should have thought about that ahead of time. This one, let's see. The numbers 4 over 2. Oh no, I'm an idiot. This one is not that, because when we do 4 over 2. We get 2, but when we do 16 over 4, we get a value of 4. This is not geometric. This one is a neither. All right, it is neither. So because the ratio between these is not constant. Okay, so that's good. That one got me. All right, let's see. This one looks like it's adding 10, 10, 10. Yes, this one is arithmetic with a constant difference of adding 10. And this one, let's look at this. 100 over 500 would be 1/5. 20 over 100 would also be 1/5, and 4 over 20 would also reduce down to 1/5. Boom, boom, boom. That is a constant ratio. This one is geometric. I actually like how that one got me. You get to kind of see that. All right, so complete each arithmetic sequence. So if it's arithmetic, there's going to be a constant difference. Going from -2 to 4 means that it's adding 6. So the next number, 4 plus 6 would be 10. Plus 6 would be 16. 16 plus 6 would be 22. Let's see this one. How much is it adding from 11 to 111? That's adding 100. So we'd add another 100, get to 211, and then 311, and we're at 411. And those are working. Again, 7.5 to 10. Well, if this was 7 to 10, that would be 3. This is going up by 2.5. 2.5. So 10 plus 2.5 would be 12.5. And 12.5 plus another 2.5 would be 15. And if we take away 2.5 from 7.5, we get 5. Okay. All right, and now let's see. We need two numbers that are near each other to find the constant difference. So this is going down. It's a decreasing pattern, getting further into the negatives. It is going from 13 to 23 would be 10, but it's 1 less. It's losing 9 each time. So the next one would be -31 and 5, and if we take away 9 from 5, we would be at -4. Okay. This one says, hey, they are geometric. We want to think of looking for a constant ratio. 25 divided by 5 is 25 divided by the previous number, 5, is 5. So we are multiplying these by 5. 25 times 5 is 125. And if we go in this direction, then we're dividing by 5. And 5 divided by 5 would be 1, or 1 times 5 is 5. Negative 36 turns to 216. Let's take that ratio and do 216 divided by negative 36. We get a ratio of negative 6. That means as we go from here on, we're going to multiply by a negative 6. And a negative times a negative would make a positive. 1 times 6 is 6. And 216, negative 6 times 216 would make a negative 1,090. Negative 1,296. Okay, looks like these numbers are getting cut in half. Half of 5 is 2.5, or $2.50. Half of $2.50 would be $1.25. Okay, and then half of that would be, yeah, 62.5 cents. If we're thinking money, let's see, 36. So look at what I do with this. I take that number of 108, and I divide it by negative 36, and I get a ratio of negative 3. So that means going forward, I'm taking and doing negative 3 times 108 to get negative 324, negative 324. But if I'm working backwards with this, I'm going to take negative 36 and divide it by negative 3 and get 12. And then I'm going to take 12 and divide it by negative 3, which is negative 4. Negative 4 if I'm working backwards. Okay? All right. That, I'll be honest, that's a lot of work. That's a lot of work there. All right. So thanks for hanging in with that. It probably took you, maybe like 10 minutes or so to do that. We'll see. Although I am talking through it, so that extends it. For each sequence, describe a way to produce a new term from the previous one. So we got this one and that one. When I look at this, we've got 4, 8, so this must be 6. That means that this is one that's just adding 2, adding 2, adding 2 each time. So sequence A, so A starts, what does it start with? 4. Starts with 4, and then it adds 2. For sequence B, just for sequence B, let's see, it looks like it's at 1, then it doubles to 2, then it doubles to 4, then it doubles to 8, so it is multiplying by 2. So it starts with 1, and it multiplies by 2. Multiplies by 2. Which of these is geometric? Well, which one's geometric? B, this one, because it's got that multiplying and also the curve. That like role model answer would say, we can literally just see it on the graph before we did any math. We can see that this linear one is arithmetic and that one is geometric. All right, that's it. Take care, folks.